In the figure, A, B and C are particles of masses m, m and capital M respectively. The particles A and B are connected by a light inextensible string. The particle C lying on a horizontal smooth table is connected to B by another light inextensible string passing over a smooth small pulley fixed at the edge of the table. The particles and the strings all lie in the same vertical plane. The system is released from rest with the string taut. Write down equations sufficient to determine the tension of the string joining particles A and B. Solution for this question: the horizontal table, at the end one of the pulley, here one of the particles C is kept here, connected by a string. Other end carries a particle B, and by another string one more particle is carried out here. Observe the movement. Up to a certain level we stopped here. Weight of the particles. Weight of this particle capital Mg. Weight of this particle small mg, and weight of this particle B mg. Reaction on particle C is R by this table, perpendicular to the table. Tension on the string connecting particles A and B in this string, tension T1. Here T1, here also T1. This T1 acting on this particle, this T1 acting on this particle. Tension on the string connecting particles B and C is a T2. T2, here T2. And also we must mention here also T2, T2. The pulley. As strings are inextensible, acceleration of all particles are same, F. Same acceleration for all three particles. Therefore, this moving down F, this also moving down F, this particle moving horizontally with acceleration same F. Now we are going to use Newton's second law, F is equal ma, for the particle A vertically downward. So what is the resultant force vertically downwards acting on the particle A? Mg vertically downward, T1 vertically upwards. Therefore resultant vertically downward is Mg minus T1. Therefore here particle A, Mg minus T1 is equal mass m into acceleration F. When we simplify, T1 is equal m into g minus F. For particles B, we are going to use this Newton's second law. So the resultant force vertically downwards, mg vertically downwards, T1 vertically downwards, T2 vertically upwards. Therefore, resultant vertically downward is equal mg plus T1 minus T2. mg plus T1 minus T2 is equal mass into acceleration mf. When we simplify, T2 minus T1 is equal m into g minus f. For the particle C, we use this Newton's second law in the moving direction, therefore in the horizontal direction. What is the resultant force in the horizontal direction? R and mg not coming because the perpendicular to the horizontal direction. Therefore, these components won't come. Therefore, horizontal components of this force T2. T2 is equal mass capital M into acceleration F. Therefore, these are the three equations. T1 is equal M into G minus F. T2 is equal M into F. T2 minus T1 is equal M into G minus F. Here three unknown, three variables. T1, T2 and F. We got the three equations. Therefore, we can find out all the tension and acceleration of the particle. These equations are sufficient. For the note, exercise for students. Students can find out T1, T2 and F.